Hey, so you're gonna have to excuse the messy hair and everything. I walk my dog and all this other stuff. But I was thinking about how to use a type of vacuum energy. It's not really what that is, but concept-like kind of thing in electrochromodynamics, or is it just like basic electrical engineering? I'm not sure. I'm not sure where Anyways, point is, so the basics of the principle, if you want to call it that, which is not really probably what that is. It's really just like a fun thing that I thought would be really interesting to do. So imagine, if you will, you have a really tiny short cable. Okay. Now, we don't like to think about it, but a short cable, as electrons dot or dash happen to move through it, it only manages to move this one little thing, right? Except not really, of course, as it goes through, it creates a plug of air, and then it all bunches up, and then creates a bigger dot, effectively. That kind of thing. Which is why we view it as volts. Okay, and then amps are kind of like, multiples, and anyways, moving on. Okay. But because of that, that's also shifting on the other end a large amount of quantum tunneling electrons in their orbit, right? And it creates a bunch of different spin states and a bunch of different electromagnetic field changes, all right? Now, field changes are interesting, but usually nothing that we really give a fuck about, for what it's worth, right? But fields, of course, are something that we view as excess, right? They're the equivalent of a 10% loss to us. And we coil things around, and then we try and use that 10% loss and amplify it. And we dump it into this, quantum tunnel, but not really. It's a field collapse that creates greater and greater amounts of electromagnetic field, all right? Which is all very well and interesting. However, here's the thing. It's not that interesting, right? Right, like the vast majority of people go, well, whatever, we've dealt with it forever. However, if you happen to make it such that you use that field potential energy that's moving through that cable on the other side of where it's connected, and set up a bunch of different things to use as the kinetic, quotation marks there, force of that electron moving through happens to ultimately get there, it then collapses a bunch of states, of probable field states. Now, that means you set up a bunch of superpositional states. Now, the reason why I'm wanting to talk about it is because we're not using that in any aspect. Okay? Which is a big deal, actually. In fact, it removes the idea, so to speak, of heat, kinetic movement, and chaotic. Okay, so like the field as it's getting set up is now moving any jostling and tunneling, in a manner of speaking, to no longer be there as much. Okay? Now, a way to put this really easily is if we go with the Newton's cradle and it goes through. Imagine if we had a good solid tube around it, and we can control the air very, very well. Then on the other side, let's imagine there are other balls and some air and all that. And as it's moving it through, of course, it's setting up a bunch of air that's now there, and what's in front of it is basically like a vacuum. Once that kinetic movement has moved to that point, really it actually fills up all this air that was supposed to be over there, and it uses the potential vacuum energy to arrest the movement of the Newton's cradle. The Newton's cradle doesn't move anymore. It moved just enough, and everything collapsed, and all these balls fall or do whatever else they were doing. Really cool stuff. Very possible. We don't use it at all. Nobody uses it. And I mean that. It doesn't exist. It's a thing. But like, at the same time, it's not because it doesn't work, it's just because it's like, well, why would we ever use this fucking field thing? Like, what the fuck is it? And you know what I mean? Like, I have to get a special connector that goes, and this has to be around, and we have to do all these little fucking coil and all the fucking stupid thing, right? To get basically a bunch of little CPUs strapped around a fucking cable. Also, that way, deliver it properly over to here, and then, like, all of a sudden it goes zit and boom, and it does its job. Right? And I'm like, that's what your neurons do. That's ionic exchange potentiation. If you want to know, that's how electricity gets used at its most efficient. As electrons move one way, it then sets up a potential collapse of multiple ionic exchanges in a given array of neural networks with glial and other cells, effectively, that are neurons. Now, as there are different loops around, that's a memory, and there are different potentials that are there, and so then it collapses and it does its sort of, field collapse effectively, right? And that creates a bunch of superpositional drop states. Now, it's a really cool thing. However, it's mostly because our brains would overheat. If we had to do all that exothermic reactivity as quickly as we do, it would suck. Our brains wouldn't like that. They, generally speaking, like to be as cold, like any other computer, right, as they can be. So that way they're stable and they don't decompose all the, organic molecules that run them. That's a good thing, right? Now, the reason why I'm talking about it is because, well, here's a gigawatt hour of a tiny little transistor, 10 nanometer, whatever the fuck. But it's like, well, if I put the right little fucking, whole thing around it, like a gate, right? Then it's like, oh, well, all around all of that, in a three-dimensional manner of speaking, I managed to get a bunch of, that's right, transistor gate arrays to collapse their states. And, well, yeah, no, it's a gigawatt hour. And I'm like, yeah, because, like, it doesn't really happen to move much, is a way to put it. It's not really like, it is, okay, so like, I have to be really careful here, because like, it is moving all these electrons, except it didn't really do that. What it did was, it allowed for it to go through so much faster as a result of that, and then it immediately knew that everything had been moved, and all of its energy had been taken, that it didn't move anymore. As a result, it didn't explode effectively, right? Like the cable doesn't go boom. And the reason why I wanted to talk about it is because we don't think of cables as batteries. We're treating a cable as a battery. It's a field capacitor battery. That's a field effect battery. They're just really good and fast at doing it. And it's the reason why is because it's like, take like a smart water bottle, 1 liter or whatever, that kind of thickness, but then extend it for a whole light year. And then I want to put a yottawatt of energy into it, right? Electricity. But it's like, it takes a really long time to do that. I mean, it takes, it's a year, a whole year, right? It's a light year. It's roughly, it's not. I mean, it's going to take a while, a whole thing. And it's if like vacuum, blah, 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 all that stuff. But it doesn't matter. None of that means anything to any of us. The point remains, it's like once the field is there on the other side, you can start taking that and setting up more and more and more. As a result of it moving the electrons and continuing to feed it, what happens is that you can take that, and every single time it collapses it, it happens to use that energy, which acts as if that the actual energy traveled faster than light. It didn't at all. Actually, what it did was it moved something as quickly as it could as a sound pressure wave, and then it gained a bunch of field states as that moved as fast as light could theoretically move in that given, area, that kind of thing. And so, yeah, it'll take, I guess, another light year for us to get a whole fucking, yottawatt of fucking power, but, I got a yottawatt, though. Use it in right, like screw it, right? I just say I've got a yottawatt though, but it's a big, huge cable battery is all I'm talking about. The shock horror is I turned a big, let's say it was copper, right, cable, solid, into a big battery. You know what I mean? And it's like, no, that's so lame. Don't say that it's a big battery capacitor thing. And yet, that's all it is. That's all that is doing. And it's like, I don't know if that's whatever, or if it's like electrical engineering, but it's like all in how you do those things the right way. Like, you have to do it all these finicky little things, and you would probably be able to do that. Now, best practice then turns into, we probably can't go that hard. So, sure would love to, but, instead it turns into, well, you can do something else. They can shove a bunch of volts and amps through something that normally would just explode. But it all has to have enough energy on the other side, to be used to effectively make sure that when it gets pulsed through, because that's what a pulse is, right, as the volt, effectively, and it uses the volts very efficiently at that point, except it also has to have the right amount of amps to move enough to effectively make that level of energy. So, the standard is, still there, right? Like, you don't get something from nothing. So it's like, I'm increasing complexity for a given design. However, I'm increasing efficiency as a result. And hey, wouldn't that stand true for like everything always? You want efficiency, you usually increase complexity. Shocker, horror. Shock, horror, shocker, you know what I mean? It's like, oh. But that also means I have potential chaotic superpositional states that are at, that's right, regular atmospheric and regular Earth-like temperatures. Okay, you're still probably gonna have to cool the shit out of it because there's no way you're gonna be able to do that fucking efficiently. You know what I mean? But like, it's still what it is. Hey, if I zap it the right way, which isn't really what that is, but then I get a very efficient collapse of multiple states. And if I do that the right way, those states collapse to a cascading like effect that effectively works in conjunction to themselves. However, that does mean that you do need capacitors and batteries around those, but that's called like memory. Those are memory states. If you don't know that, that's like a capacitor in any kind of like CPU is shock horror again. Effectively memory inside of a CPU. There isn't much of a difference. They're sort of just there like as potential states, and then when they get energized, then what do you know? They modulate the effect of any given transistor type. And that changes binarily speaking the output pattern sequence of the dot dashes that you receive and what that means for another one down the line. It's basically all it's doing is your magic rocks. So pretty cool stuff, but like the reason why I'm talking about it is because it's not an energy band gap that we're talking about. You can't use an energy because it's no longer a band gap. There's no band gap. There's no energy gap. There's nothing like that. In fact, if anything, it's just flowing it through and nothing changed except for like, a whole bunch of possible memory states like-ish that are in a transistor gate array happens to then collectively collapse together. But, depending on how ultimately you set those up, but you can change that based upon the memory that you use to modulate either before as it delivers the power or before as the power gets delivered to those things. See what I mean? So like, it's effectively a way to run a type of CPU that would never have been thought of before, but it works off of how our brains work. In a three-dimensional, fourth-dimensional, because of course it has to move, that's the standard, delta that seems to always exist for everyone. Hey, shock horror, our brains can't, but, still works. And it works really rather well. Now, the reason why I call it a chaotic superposition is because it technically is. It's waiting for a jump to any given area, and it orders itself as it gets and gains a chaotic potential. That's all it's doing. It's gaining a chaotic potential that then collapses to a more ordered state. Depending how you set up that chaotic potential, you gain an ordering that you then have known as a given value that also gets potentiated by more electrons and all that, and then it spits out a value. It's a actual superpositional workaround. Let's put it that way. It's a workaround to superpositional qubits. Like, they're super hard to make. So I was like, fuck this! Can I make them just turn into like a reverse? These are really hard. These are really hard to make. These suck. They are the worst. Just imagine there's like some science, people off the screen over there. They're not. But like, just imagine, It's like, can you guys really, you want me to what now? This is hard to do. I don't want to do that. How about I just turn it into a slightly more, and I do it really quickly. You know what I mean? And it's very consistent depending on how ultimately I set up the chaotic, potential. It's basically the same thing that you're describing. I don't see what the difference is. What difference? You can't make another. It's a Lemke superpositional chaotic state. Suck it, suck it, suck it, suck it. I'm just going to name it after me because it's like, fuck you. It's like the moment someone's like, no, I'm like, no, I'm going to do it anyways. Because what you're doing is effectively you're annoyed and frustrated that someone found a workaround to your stupid problem. And like, screw it. It's now mine. It's my solution. It's only mine. Get away. I'll be the only one to use it now. It'll be my greatest avenger. I looked at my brain super hard inside of my brain, and then I figured it out. It told me everything. I tuned into the frequencies of the universe, man. Right? But like, kind of a little bit. Like a little, it's not quite that, but like, a little. So I think it's pretty interesting. I thought others might think it's pretty interesting. And the only reason I was thinking about it is because I got really, really, really anxious and stressed out about this situation with my SSI. And then I didn't sleep for a while, but I have slept and I'm getting better. And I was like, what the hell is the difference between a volt and amp? I can never seem to figure this out. People keep describing this to me and like, it's never worked well for me. So how did, well, it's not it can't be force because all force is mass acceleration squared. I don't care. All of it works off of momenta, mass acceleration squared. Potential is still basically the same thing. It's a given area, which is a given mass potential of everything in that given area that moves a given amount of way. And the amount of conversion loss of other field and collapses and so on. And that's all they're ever describing. In every single quantum field and fluid and blah, blah, blah theories that they have ever made. They all like to describe it like, it's not like that. But that's literally what they're describing. Which has bothered me. Because it's like, it's not force. Like, you're not talking about force. Like, you can't accelerate the damn electron. It's not a particle accelerator. So you're not getting more force. What is it that you're doing? I'm gaining more mass. And that's how I had to describe it. That's how I describe it, but how I had to come up with it and describe it to myself. It's like, it's definitely a chunk value as it happens to move like a plug of air as a wave pressure tends to ultimately do. It then groups together something, and then that becomes what's going to arrive. Now, depending on the type of field and the type of total amount of movement on the other side, when it tries to deliver it through the given cable, that's what gives it volt. That's it. It doesn't matter if you do it a bunch of chunks and then they all spike wave energy. Sure, whatever. You know what I mean? It converts a bunch of amps as a bunch of electrons, and then they all think of it like a mass airflow kind of thing. With a parabolic curve funnel. Then it goes from a bigger to a smaller, and then it goes smack harder, basically. And that's it. You know what I mean? Like, they're all basically the same things. Like, all electrical engineers have ever described this as is this. Even if, it's not easily, often understood that that's what that is, because what they'll use is a bunch of fucking random names and, I don't care who that person is. I'm not going to look up that. What is this stupid number? What is this stupid symbol? I don't give a fuck. Do you have a hard time, actually being able at all to describe this properly? And it has nothing to do with you, because you were described it like this, as like that, right? And it's like, it doesn't make sense. Everything you're describing doesn't make sense. I just want you to know that. I know for a fact that it makes sense after a while, because there's effect that's definitely working and it's doing this, and I'm like, yeah, but it doesn't actually do that, and I know that. Everybody knows that. There's no electron that's definitely getting sped up. Give it a rest. It's not a particle accelerator. Just fuck off. You know what I mean? Stop using force. Volt is not force. Shut up. You're just gaining more of those electron tunnels in a given chunk that arrive at the same time as one given point of quantum informational energy that all collapses their states as to existing right there at that point. That's it. But it's like, I can't describe it. I'm like, blah, blah, blah to you too. I don't like it. I don't like the way they describe it. But that's the same thing with amps. It's like, yeah, this is a bigger chunk that's now longer. Basically. Except not quite. It's like, no, it's quite a bit long, but it's the equivalent of, look at this small, tiny black hole, and look at this huge, ginormous black hole. When you get to the event horizon of the huge, ginormous black hole, well, guess what? The, gravitational tension, blah, 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 pressure, blah. I always get bored of that. Imagine that it effectively is like no longer having a big elephant stand on you with a pencil for the black hole. That's big. Versus the small one, which now it is that. So basically same thing. Volts are kind of a similar story-ish. It's like there's now less of that powered amount of pressure in one single thing, right? And so like it's very compressed. Versus this one, yo dude, just chill out. It's a big huge rock just flying towards someone. I would have preferred the tiny pebble. Are you sure? Because I gave you a big, huge rock, and I just threw it myself, versus a pebble that I got this cool tube, and then I, loaded some expandy, chemicals that are bound together. Once I happen to do some things to them, they expand rather rapidly and quite, chaotically, and then it goes through this tube and it arrives to you very quickly. And it seems like, honestly, you would have probably preferred the bigger rock. Meanwhile, both of them injure people and probably kill them. So, I don't know. Right? But that's effectively all volts and amps are, because that's literally describing the quantum process, and the classical process doesn't really make sense. It's not doing what they're saying that it's doing. It just doesn't do that. And it's like, no, I understand the wave part. And it's like, I absolutely agree. The wave thing is a thing, right? But, but it's like, no, but the electrons are moving, right? And it's like, well, kind of, yes, yeah, ish. Like here's the caveat-y little thingy that it does. To imagine it more like a compressed spring, and there's this other area can kind of and then the spring kind of yanks down a little bit because you compressed it too far, and it goes but it keeps going back up to where it once was, and it keeps doing this as it tries to balance itself out, right? And so then it's so I don't know. Basically, that's the classical version that they have, but because that spring did that little thing right there, that little wave oscillation, you get this, it goes back up and it kind of rotates a little bit, and then you get field, because imagine the spring was in air, and so then you get this big sound effect, right? And then a bunch of them are all doing it together. All of a sudden, they start all being able to do something cool, like acoustic resonative tweezers. Or, heating, vibrational heating, and or other things even attract it, because it's impelling air away from this area, creating a vacuum force, which is cool to think about, right? That's how you have to really kind of describe it. But that's the classical kind of version, but then the classical version doesn't really work, because there's a ton of electrons, and there's a large amount of fields everywhere, and all this other stuff. So, it just doesn't do force the way they think that it does. And I get kind of, perturbed, obviously, because, it just doesn't describe it very well. And, no, but and if somebody had described it like this, you might have honestly gone well, if, then I capture a little bit of that, and then, the moment and then, boom, it would have been something we could have used, right? But, no, that's not how they describe it, right? I was like, no, I shall use this electromagnetic now. I shall use this wasted energy, which is kind of weird in a way, but if you get a bunch of coils really fairly close, and you make sure that it doesn't jump a gap of the electrons themselves, but instead the fields, it then potentiates, and it creates a different type of resonance as it goes through with the electrons and their virtual quantum information, or virtual information. Anyways, information. It's quantum information. It doesn't really matter. It's not technically there, right? But it's this possibility, which is how they describe it. But in reality, it's like this pressure happened, and, right? And so it's waiting to effectively have that dunk on the other side occur. And so as a result, it's doing a whole bunch of movement of springs, essentially. And then a bunch of outward bound, versions of area of effect happen. Right? Which is why it's like, it's not a particle anymore, it's now a field in a given media. But that media is a bunch of other fields. So, how does that work? Get out of here, you, with your stupid element and particle stuff. Yeah, but that's... What? But that's all that is. Hey, you come back here, you. Where are these fields coming from that are in this vacuum? Where is this happening? Nobody knows. No, I swear. I've got some ideas. Oh, yeah, same with me, too. I'll throw my hat in the ring. Hey, sure. Whew. Right? But the reason why I wanted to talk about it is because it's like a really interesting concept of how to effectively deliver power a little bit more efficiently. It's not a superconductor. There's no superconducting, and it definitely gets a little bit hot, and you can't perfectly do it. That's the point. But that's fine, because I don't need it to be perfect. I don't want fucking perfect superconducting bullshit. These things are fucking hard to make. Get out of here. Good enough by my ass. You know what I mean? Like, this is, like, best I can do. And, like, no, I'm way better. I'm like, fine, take the fucking goddamn first trophy. I don't care. Look at how much complicated bullshit you have to do that versus brrr the right way. And it's like, second place, still getting it done. Fucking making it all happen, man. I don't have to get, like, super complicated, hyper perfected molecular structure. Super cold, absolutely goddamn massively controlled denoid. No. Don't want it. No. I just need to be, effectively caged up enough. You know what I mean? Like, that's all it needs to be. Like, it doesn't need to be a perfect superpositional qubit. It doesn't have to be. Like, it just needs to land in a given area of effect, because it's essentially going to tunnel a little bit, right? So it's like, if it's this, then it's like dunk, but it's like, because I set it up a little bit like this, now this is one of these more like this. So it's like, as long as it lands somewhere around here, then of course that's what it did. You know what I mean? I don't need it to land perfectly right here every single time. I don't need to land like right exactly there, only this exact, that's it. No, I don't. Fuck off. No, I just needed to land close enough and I get the fucking result. That's all I have to do. They're like, no, it has to be this tiny little fucking thing. It's really exceedingly hard. Are you sure? Everything you're describing says it doesn't have to be like that. I'm just saying. No, it does. You might be a little, like, difficult to work with the are you possibly diagnosed, no disrespect to you, but do you have possible some serious severe autism? And I mean this, not trying to be mean, but when you really can't, like, allow for any amount but other than, like, this super extraordinarily hyper precise and only rigid rule following, and you can be nothing else, and no open mind, and very black and white, and all this other stuff. Are you sure? Are you sure you don't have a little? I'm not trying to be a dick, but it's like that might be a reason why it could be a little bit difficult, okay, for others to come into this and effectively ask questions, possibly, maybe come up with a solution that will work just fine, but you don't particularly like it because it's not your way, which is a problem that a lot of people, that have to deal with people like that, know all about, for what it's worth. And more than that. I don't disagree that is exactly for that phenomenon that you talk about, that is exactly that type of superpositional qubit state, that's what you have to do. I agree. I'm not going to get into that. I'm getting into this, which still is 100% a superpositional state. It's made to become a superpositional state that collapses. They can only become a collapsing state that happens to coincide, of course, with the setup process that we get and give it. It just needs to be clean enough, denoised enough. It just needs to be controlled enough, which is basic coolers and so on for fans and CPU stuff. Right? Like, that's all that has to be. We can do that. If that's the case, then it's like, sorry, but you're not in first. Since, sometimes they like to do that as a competition, to allow for, like, I'm better and, I can hold my own and I don't have to defend myself because I'm above you. Because, like, they're often brought down and, made to be made fun of and more. And it's like, no, I'm not trying to do this to you. Okay? This one turns into, actually, serious concern here. This might be holding a lot of people back. That kind of thing. You know what I mean? Like, that genuinely can hold a lot of people back. Like, I don't want to approach this whole thing because, like, why? It's really aggressive. I don't like it. I don't want to get into it. I don't want to, like, it seems scary, overwhelming. It has to be this hyper, specific thing. It doesn't make any sense. And, you know what I mean? But it's like, generally speaking, once you kind of understand and grasp some of it, really easy to know and understand. Like, it's super easy to get. It really takes nothing. But it takes someone like myself usually to go like, okay, I heard you. Let me tell them. Hold on. So it's like this. No! Yeah, it's like... Hold on. Please, could you a little just okay? Can you go to another? You're gonna get triggered. Okay, all right. Go over there. So it might be a little bit like this. It's very likely what that is. Effectively, it can be described in multiple aspects that are basically this. It's a type of state that is not yet defined. Nothing's really observing it, and nothing's going to influence it. It can't be known as to whether it is this value or this value. It's superpositional now. As a result of it collapsing towards a given area that, of course, while we're setting it up, and we can't know if whether or not it's gone through until it's gone through, that means we have a superpositional qubit state. But it's a superpositional chaotic state. It's chaotic because we're using fields that are never at all in one place or perfectly set up. And now they're going to become more ordered as they collapse, hopefully to one of the areas of electrode to ground them effectively. Except it's not quite grounding. Bit weird. I get that part. I know we can't call it grounding because it's already ground. The whole thing. But imagine it like we did ground a given possible, arc effectively. Now, it's not really that. It's really fields that then collapse towards that given area once that state had reached its point of superposition that then can equal a lower resistance state that we have in the area, right? And that's what the transistor would be doing. So, which is easy enough to understand, harder in concept to imagine. Effectively, they're already there, potential electrons, and then we effectively made it so that electron movement is now known as a quantum informational state that moves through its given cable, that then goes to and through other cables that then amplify effectively that amount of electricity going through it. Something that we could actually use, So, weird way to put it, but still yet it's accurate enough for the vast majority of people to grasp and understand. It's like, have you finished telling them? Yes, actually, yeah, honestly. And it's not like that, by the way. Everything about that's bad. None of that works that way in no way, shape, or form. Thanks. Do you guys get it yet? Yeah. Yeah. Don't laugh at me. I'm not laughing at you. You know, it's actually laughing at the situation more than anything. But it's like, no, that would never work. That's not actually how that would. It has to be only critically defined, only specifically at this particular. They put a bunch of math up. I'm like, and then if I move this over here with this math, and then effectively, because it's a field state now, which of course is defined in a non-defined, undefined manner, which is a Heisenberg, by the way, it then becomes a Schrodinger's little psi. And you know that. Shut up. No. I have to go look that up. I'm sure, but you know, that's effectively all that is that's going on. However, no, I've never thought of like using a field contained in an area as a given, like, undefined, unable to be observed point that has a qubit superpositional point. Really? It can only be exactly like this. Yeah, no, but what if it wasn't only always like that? That, you know, like some of you probably have had that conversation with others, and then you're like, oh, I'm that person. You know what I mean? And it's like, you might. Here's a video as your sign. You might be that person. Okay? So, the only reason why I was talking about it is because it's very easy to understand and grasp as a basic concept of how to deliver power more effectively and efficiently, and possibly even make really cool transistors that are totally different than what normally people assume it as. Because, like, I get that, like, oh, no, because it would be a field programmable. It has to be this other thing that I already know about. And I'm like, okay, hey, it's a field programmable. Okay, but in a now superpositional context. No. No. Okay. However, what if? What if it was definitely understood that we don't know what that state is, and only as a result of delivering power do we even know that it even existed? So it's definitely as a potential thing that we don't know as of yet which and way and all the rest it went. Well, yeah, but it exists there once we just started delivering power. But we have no idea where and when and how much and all the rest. Even though we're trying our best to effectively mitigate that by saying, well, you know, this, and then some of these memories should hopefully, you know, do a little bit of that, right? But it's like, yeah, but it's not, though, really able to do that. No, it can't. It'll definitely have a degree of state that's there, and you know that, as both field and charge field. Right, this is electromagnetic and charge, which you don't seem to get. So, like, that's the problem. Like, I'd have to have like a discussion with people about that, because it's like, no, you're getting it wrong. Like, it's a field gate or like or a felt effect transistor gate based, you know, and so. Like, oh, yes, no, I'm fully well aware of how those work. Okay. I'm changing charge values, by the way, with inside of the area it could possibly collapse to. You know that, right? Which effectively limits, possibly, the amount, okay, of energy barrier, otherwise known as an energy gap, otherwise known as a barrier gap, whatever version for a field fucking gate, or a transistor gate, is. It doesn't matter. P exclusive, this, that, I don't give a fuck. They're all the same. And I mean that. So it's like, if you want it to collapse over there, okay, it's like, well, but we're changing states on the other side. But it's like, it's more weighted and likely to do that. It doesn't mean that it will. And in fact, because we're also changing charge states with inside of that area too, for where we're delivering that field potential, that also modulates it, and definitely we don't know what it's going to be for its value. We just know that it exists. We don't know as to, ultimately, depending on how that's delivered, we go, oh, yes, no, we should be able to know how it's delivered. What the little, we go, it's likely to be this, but we don't know. That's the point. You don't understand that part. Just because we made it so it's delivered and it's likelier, it doesn't mean in any aspect that that's what it will do. That's why it's chaotic. That's the point. Yeah. It's a very weird concept for the vast majority of people to kind of grasp. But the equivalent is essentially a bunch of air that's going to go backwards. And depending on how it goes backwards, it'll collapse a bunch of balls. You see what I mean? Now, that's the ionic transition. Our brains express or do not express a certain amount of a given neurochemical, or a given allowed reduced electrical resistivity to continuation of a propagation of electrical wave signal. Something that, you probably don't get super easily, which is okay, because most people don't ever have to do with anything. Literally, this is super, out there, never part of your regular everyday life stuff that you deal with. So, it's not your fault for not really grasping. You know what I mean? But it's okay, I guess I have to phrase this a little better for a lot of people. Right? So, let's put it this way, super simple. A charge, which is great, but that's positive or negative, and that can be modulated based upon the memory. Same thing for the power delivery, which can be both negative or positive. It can both jump towards or away. It can remain as a state, of course, as a field, and that modulates the electricity moving through. As a result of that, there is no such thing as anything other than a superpositional Q state here. As we don't understand in any aspect as to what is going to fall where. We can't measure it. There's no way to actually measure that without influencing it and collapsing its state. That's called a superposition. That's how superpositions work. You want to measure it the right way? That's your transistor type. That's your gate. We can't do anything other than allow for it to collapse the right way, is what you say, right? But it's we don't know how it's going to collapse. That's the point. So we collect as much as we can around it, and we go, based upon that, and we're pretty sure it would be like this, but after enough of these, and then it's likelier to be this. And that's how quantum computers work. So we go, and let's say there's 90 different capture points. But that represented effectively 9 different qubits. All right, so 9 qubits then had 9, that many different collection states. But then of that 9, we ended up getting, you guessed it, only 76% of that. So 76 out of 9, well, no. Right, 76%, but it's not 76. Anyways, the number, into the placement we thought it would be, right? So we're going, it's likely to be that, though. And it's if I do this enough times, though, and if I layer it 3, so I got 27 total now, and I'm going to do it again, and it's well, no, it's likely to be that still, but it's a higher percentage. And now you know how qubit computers work, right? If you know that, then it's right, well, that's a fucking arduous process. Fuck that shit. I don't want to do that. Screw that. Everything about that sounds stupid. Why would we do that? Wouldn't we want a black and white, in one little area that happened to be a thing? Well, yes. Yes, we would. A lot of people are trying to do that. So, here you go. Basically, fuck off this. Screw that bullshit. All it has to do is get close enough, and that's good enough. Because you're already doing that for your qubit states. However, instead of like, I'm modulating it with multiple different detection methods, basically, which effectively change how it's going to maneuver itself in its 3D landscape, as electricity will flow through not just one area, but multiple different areas. That creates a already given value that is the most likely to occur automatically. Out pops a very, 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 very high percentage chance that's, well, not 100%, it's feasibly impossible to effectively have it be anything other than correct. And those that do know how qubit supercomputers work, they were already on board. Those that would have argued up to this point now probably look like they have a lot of egg on their face. They're like, I don't know how you, and it's like, it's okay, it's fine, you don't have to do that, you don't have to explain, you don't have to defend. None of that's relevant. As a result of that given charge, that sure modulates things. I get that part. But not just how it's delivered, which is great. It's very quick. It's very cold. Technically, not really. It didn't really ever do any of that. But as it has to go back, those charge field states change, of course, the result of backflow and how quickly and where and when it does it, which is how ionic exchange and the result of resonances of our brainwaves happen to work. Theta, delta, the whole thing. But now, as the collapse effectively creates a increase or decrease of potential value, of course, that potential value has to arrive somewhere. The potential value then has to do it again. Okay? However, what if it just went backwards to the same place where we delivered the power? Of course, it will have lost quite a bit of its electricity, which is good. You actually want that, right? You don't want to send like a fucking gigawatt hour into the thing, usually. So, instead of that, like, what if you didn't get that? What if you got like a regular volt that wouldn't destroy everything? Like, what if you just got that instead? Now, that's great. But the only way that could have happened and been in that sequence and pattern is if this, ultimately speaking, calculation was performed like this. That means you had two different states exist and occur simultaneously that exist as superpositions. As one goes over, it creates and it drops down. It was very brief, but it existed, and it became more ordered. As it became more ordered, this became more chaotic. This more chaotic then gained a more ordered state, and it delivered to you the information. Do you get it? It error-corrected both when it calculated the first time and the second time on the way out, thus making it functionally very, very unlikely for it to ever have been incorrect. Brains, man. How do they work? Crazy shit. Bye.